All right, let's talk about our first section on absolute value, which is absolute value equations. So first things first, let's talk about what absolute value is. So absolute value is the distance between 0 and a number on the number line. So for example, the absolute value of 4 is 4 because 4 is 4 away from 0. And the absolute value of negative 3 is 3 because at negative 3, we are 3 away. So absolute value, which is normally abbreviated ABS on all calculators and computers and stuff, is always positive because distance is always positive. All right, so if you're looking to solve an equation, what we do is we split it up into a positive and a negative branch. We're going to do this all through here. Okay, so basically this one's real simple. Those are the answers. It's 5 and negative 5 that work. Take the absolute value of either of those, you get 5. There's no other solutions either. It's just those two. Okay? This problem is the same way. Either the inside, x minus 3, is going to equal 1, or it's going to equal negative 1. Because 1 and negative 1 are the only things that could go on the inside of those absolute values and truly equal 1. So with this, you'll have to solve a little bit more and put those 2 points on there. Okay? If you need to solve an equation a little bit, totally fine. We're just going to isolate the absolute value piece on the left. So again here, we're going to say, hey, if we put a 3 in the absolute value, or if we put a negative 3, so if the inside equals 3 or negative 3, it'll make this equation true. So that's exactly what we're going to do. And graph those like that. Okay. You can also, or this isn't anything new, just go ahead and solve for the absolute value piece. And we have to stop here because I've contradicted something that we've said. I told you that absolute value is always positive. So how on earth could we get a negative number out of taking the absolute value? It's impossible. So there's no solution here. So if the right-hand side is always negative, there's no way we can pick an x value that's going to make this work because absolute value of anything is always going to be positive. Okay, so you can also work in reverse with these. So the formula is x minus the midpoint equals the distance. So we'll kind of make sense of that as we go. The middle of those two numbers is 0, and the distance is 3. So the formula, as it said, is x minus the midpoint is 3, which of course can be written like this. The reason why the formula makes sense is because this read aloud would be the distance from x to 0. That's it. As an equation, it would be a sentence. It would say the distance from x and 0 is 3, which really describes those blue dots, doesn't it? Those are our x values. Those are both a distance of 3 away from 0. Okay? You could do the same thing here. The midpoint is 3, and the distance is 2. So the distance from x to 3 is 2. The distance from x and 3 is 2. And 5 works for that, and so does 1. So just continuing on here, this is the midpoint. So I'm going to put that in the middle, and the distance looks to be 3. So this one will make a plus sign in the middle. But I would read it from here. The distance from x to -2 is 3. And finally, the middle of these is actually right here, because there's 4 away on both sides. So the distance is 4. The distance from 1 to a blue dot is 4. So that makes sense. Okay? Sometimes we can have extraneous solutions. Okay? Extraneous means extra. In math, it also means that there were solutions that we got from a technique that didn't really end up being true. So check you need to check your solutions when x appears on the right. So both of these examples, we're going to have to check our solutions because there's an x on the right. So we're still going to stick with our strategy of picking the right side in a positive and a negative way. Hoping that this equals this or this equals this. Wait. Yeah. We're hoping that these two values are the ones that make, like, that's what you would put inside here to make it equal to 5x. And yeah, I mean, it is true the absolute value of 5x is 5x, but x can be negative, and it's really the negatives that are really going to screw this up. So even though I wrote this down, it's not actually totally true, but it is our technique, so we're going to stick with it, and then we're going to have to pay the price by having to check our solutions, right? So it's not a, like, perfect way of solving. Like when we solve a regular equation, we know, like, when we solve it, like, that's the answer. But because this technique isn't perfect, we do have to check. Because if we get negative answers, you'll see why it doesn't make any sense. But go ahead and solve. So it's an OR statement. So let's check this one by just going up to the very top and plugging it in. So when this happens, we get 3 plus 2 is 5. Absolute value of 5 is 5. So this is a big check mark. So this, I would like double circle this or something, highlight it. That is truthfully a solution. Let's take a look at what happens with this. So plugging in, and this turns out to be 5/4, and this turns out to be minus 5/4. Is that a true statement? No, it's not. The left-hand side is 5/4, but the other side is negative 5/4. So this is not true. So I'm going to put an X through this because, don't erase it, but put an X through it because it actually doesn't work. And the reason why it doesn't work is because it made the right side negative. And the absolute value of anything you want can never be negative. So it's this that was the problem. You got a negative, and you can never get a negative to show up from an absolute value. So we only have one solution. So I'm going to put that solution on my graph. I also included a graph of this from Desmos. So this is the absolute value piece. And this is 5x equals y. Has a slope of 5, and so on, right? Those red and blue lines only intersect once. at 1, x equals 1, and that's our solution. Notice at the other point, which was minus a fourth, it goes through the absolute value, but it doesn't go through that blue line. And that dotted line is showing you minus 5x if you're curious, and it does actually intersect, but that's not our equation. Our equation does not have the minus 5x. That was a technique that we took to try and find all the solutions, but we failed when we chose this route. So that's why it's a dotted line, because the blue line is 5x, and the absolute value is that V shape. But we only have one real solution here. The other one is kind of made up. It doesn't work. Okay, so let's do the same thing for this one and see if we get any other extraneous solutions. So the inside is going to equal the positive, or it could equal the negative. Okay, so doing a little bit of solving. Just bear with me here. I don't really have anything to say about this part. Okay, 2 solutions. Don't know if they're right, but I know how to check them. Just plug in minus 8 for x. And that big negative number does kind of make you feel uncomfortable, but just because it's negative doesn't mean it's not going to work. It's all about what the right-hand side's going to calculate out to. So this is minus 42, and this is also minus 42. That is not true, because we can never have an absolute value give us a negative. This is 42. So this one's not true. So that big negative answer turned out to be false. It's extraneous. Test the other one. It also is negative, so I don't have a good feeling about it, but maybe I'll be wrong. Maybe it will work. Move this over a little bit. It is a lot to check. I understand that's a lot, but it's very important, because like over half the time we get stuff that's just not part of our answer. It's not on our graph. So this is going to be equal to what? This side is a positive 7, which looks really good because that is a true statement. So this one is our only solution. And we're going to look at more of the graphs of these at the end of the chapter, so don't worry too much about the Desmos pictures here. But all I want you to see is that, hey, this even lines up. At x equals minus 1, we have one intersection point. The point negative 8, comma 42, which was this solution that we got up here, it does not intersect that blue line. Okay? So that's all I want you to see here, is that there's only one intersection point. There are some graphs that you could get that are 2 intersection points, like this one. So maybe that was like this equation, where this was the line y equals 3, and this was the absolute value of x. That would have 2 solutions. That would be out minus 3 and 3. But yeah, so it's possible to get 2. It's also possible to get something like this. That would be pretty interesting if it hit right at the corner there. And you could also get no solution, because you could get something like this. So you had just totally not crossing each other at all. So there's a lot of possibilities with these graphs, and we'll really look at those later. So go ahead and try the homework. Probably won't take too long. It follows the video, so as long as you took notes, I think you should be fine.